Hello class, welcome to lesson 3.6, which is all about perpendiculars and distance. So by the end of this lesson you should be able to find the distance between a point and a line, as well as be able to find the distance between parallel lines. Let's look at this first example. In the diagram at the right, is the driveway shown the shortest possible one from the house to the road? Explain why or why not. Well, I was just talking about how the shortest distance from a point to a line is to be perpendicular to that line. And if we look at this driveway, it tells us that it is 87 degrees. It forms an 87-degree angle to the road. So is that the shortest possible route? No, because it does not form a 90-degree or perpendicular angle. Okay, so let's take a look at example 2. There are quite a few steps, so I recommend writing this down because this is straight out of the homework. Okay, so find the distance from point P to line L. Line L contains points 0, -3, and 7, 4. Point P has coordinates 4, 3. As I mentioned before, the shortest distance between a point and a line is taking the line that is perpendicular to the other line through the point. So point P is the point that we were trying to get a line going perpendicular through. So our first step, let's figure out an equation for our line L. So let's do our slope first, which y1 minus y2 over x1 minus x2. If you do them in different orders, if you do y2 minus y1 over x2 minus x1, that's totally fine. I'm just going to start with 7 minus not 0. 7 is my x. Need to start with y. 4 minus a -3 over 7 minus 0. That means our slope for line L, we have 7 over 7, which gives us a slope of 1. Okay, so let's figure out, we know what our slope is. Now we need to find an equation. So let's use the point that we are given. If we look, we know that our y-intercept is -3 because our x value is 0 already. However, if that x value wasn't 0, the way you would find what your y-intercept would be, you would plug in your y value from one of the points, your slope times whatever that x value is, plus b. So we know that -3 equals anything times 0 is 0. -3 equals b. So we know our equation for this step is y equals 1x. I'm going to ignore the 1 minus 3 is the equation for line L. Okay, so that's our first step. Our second step, what we need to do is write an equation for a line perpendicular to line L that goes through point P. So if we're looking for a line that is perpendicular, we know our slope has to be the opposite reciprocal. So since our slope is 1, that's the same as 1 over 1. If you flip 1 over 1, you still just have 1. But we have to flip it to its opposite, which since it starts as positive, that means our slope is now negative. So y equals -x, that's our slope, plus b. This is what we know so far. Well, we know it has to go through the point 4, 3, because that's the one that we were given in the problem. So we can just plug that in. 4, 3, so y equals 3. We have -1 times 4, so I'm just going to skip that and say it's -4, plus b. So add 4 to both sides to get b by itself, and we have that b equals 7, meaning our equation for, I'm just going to call this line W, equals y, or is y equals negative x plus 7. So now we have our two equations for our lines. The third step is we take these two lines and we write a system of equations. So, system of equations. So we have line L. I'm just going to rewrite it. Y equals x minus 3. We have line W, which is y equals negative x plus 7. So remember from algebra we can add these together to determine where they intersect. So if we add these two equations together, y plus y gives us 2y, x plus a negative x gives us 0, negative 3 plus 7 leaves us with 4. If we solve for y, we get that y equals 2. So we know what our y value is for the intersection. Now if we just plug that in to our line W, so we have 2 equals negative x plus 7. We solve for x. We bring the 7 over. We have negative 5 equals negative x. We don't like negative variables. So if we flip all things to their opposites, we get x equals 5. So we know our point of intersection is 5, 2. Now we are going to use the distance formula to determine how far point P, so back up to the top where point P, 4, 3, and point, I'm just going to call this point Q, because that's where the two lines intersect. We want to know how far point P is from point Q. So we're going to use what we learned in the first, that should be a 4, in the first section to do our last step, which is determine the distance between them. So if we use our distance formula, which, reminder, distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. So let's plug our information in. I'm just going to rewrite point P quickly, 4, 3. Okay, so now we have the square root. Our x2 value, I'm just going to use 5 minus 4 squared plus, we have 2 minus 3 squared. 5 minus 4 gives us 1. 1 squared is 1. 2 minus 3 gives us a negative 1. Negative 1 squared is 1. So we have the square root of 2 as our answer. So point P is square root of 2 away from line L. So that's a lot of steps, but hopefully you took good notes while you did this. And we are going to do another problem that is kind of similar to this. Okay, so let's take a look at example 3. Find the distance between each pair of parallel lines with the given equations. So here we have two lines that are parallel, and we want to find out how far it is from this line to this line. As we've mentioned before, the shortest distance is to take a line that is perpendicular to the line. So the way that we are going to do this, first we are going to start by finding a line that is perpendicular to one of these two lines. So I'm going to start by finding a line that is perpendicular to y equals 5x plus 4. I'm just picking that one. There's no particular reason. So a line that would be perpendicular to this line, we have a slope of 5, that means my slope needs to be the opposite reciprocal. That makes it negative 1/5 x plus 4. That means they are going to intersect. Since I kept the same b value, they are going to intersect at 0, 4. Because if I plug 0 in for the original equation, if I plug 0 in for x, 5 times 0 gives us 4. And if I plug 0 in over here, negative 1/5 times 0 is 0 plus 4 gives us 4. That means the intersection point between the perpendicular line and the line that we started with is going to occur at 0, 4. Okay, so we just found, let's say, one of our intersection points. Now we need to find out where it intersects where our perpendicular line intersects the other line. So if we take the first equation, y equals 5x minus 22, we say 5x minus 22 equals negative 1/5 x plus 4. That will tell us where these two lines intersect. So if I solve this, I have 5x equals negative 1/5 x plus 26. And I'm going to get a common denominator between 5 and 1/5. So that becomes 25 fifths. Then if I add 1/5 to both sides, I'm left with 26 over 5x equals 26. I am multiplying a fraction times x, so to undo my multiplication, I need to divide by a fraction, which dividing by fractions is the same as multiplying by their reciprocal. So if I multiply both sides by the reciprocal, I can cross-reduce. That just becomes x equals 26 and 26 become 1 and 1, so we have 5. So we know our x value of the intersection is 5. Then if I plug my x value into my perpendicular line, I can find out what our y value is. So I have y equals, do a better y than that, y equals negative 1/5 times 5 plus 4. So that gives me y equals negative 1/5 times 5 is a negative 1 plus 4. Y equals 3. So we know that the point of intersection between the perpendicular line and this first line is 5, negative 3. Or not negative 3, sorry. 5, 3. 5, 3. Now I have my 2 points, and I want to find out how far apart these 2 points are. So we are going to use the distance formula. So we have 5, 3, and 0, 4. We have 5, 3, and 0, 4. We use our distance formula. We have d equals the square root of, I'm just going to say 5 minus 0 squared plus 3 minus 4 squared. 5 minus 0 squared is just going to be 5 squared, which is 25. And 3 minus 4 gives us a negative 1. Negative 1 squared is 1. So we know that these two lines are the square root of 26 units apart. So that is how you solve that problem. I hope you guys have a wonderful afternoon.